Hi, my project is about creating an automated system that sorts objects by color. The goal is to build a system that can quickly organize items like books or products by their color to make it easier to arrange them in places like libraries, stores, or warehouses. However, I'm creating a small version of this idea that can be expanded if deployed. My name is Yousif Alrubaye, and in this presentation, I will go over the project in details, including its description and functionality, the hardware and software used, the connections and buses involved, test cases and results, and conclude with a demonstration of the system. Team members and responsibilities. I worked alone in this project, and my responsibilities were project planning and management, hardware setup, and software development. For project planning and management, I had to define project goals, scope, and deadlines, plan the workflow, including the hardware setup and the software setup. For the hardware setup, I had to uh, assemble the hardware components like the STM32 board, color sensor, conveyor belt, and the motor system. And also had to interface the color system with the STM32 microcontroller, as well as Synagogic communication between STM32 and mobile extern using the UART bus. For the software development, I had to write a code that processes data from the color sensor and sends it over UART through uh, sends it to mobile extern through UART. And I had to make sure that I have a stable connection between the microcontroller and mobile extern. Project description. For my project, the process is sorting objects by color, and the goal of the project is to build an automated system that organizes objects in stores, warehouses, and libraries based on their color. For the functionality, the system uses a TCS 3200 color sensor to detect the color of book or objects covers as they move on a conveyor belt. The conveyor belt is controlled by a motor and a potentiometer to control the belt's speed. The color data is sent to the board, to the L432KC microcontroller, where it's processed to determine the color value. And these values then are transmitted through UART bus to mobile extern, where we see the results. Block diagram. In the middle, I have my STM32, and I'm using an L432KC board. The color sensor is communicating with the board through input capture mode. The motor and the conveyor belt are communicating with the board through PWM. My potentiometer is connected to the STM32 board through ADC. And then the whole program is being outputted to mobile extern through UART. Hardware. I'm using this TCS 3200 color sensor, and this sensor detects the color of light reflected from an object, right? The way it works, it has filters on its surface and these filters let it measure red, green, and blue light separately, right? It also the sensor converts the light into a square wave signal, right? Where the frequency of the signal depends on the intensity of the color. That means we can set each certain frequency of the light to let it measure a certain color. The sensor pins, it has VCC and ground simply to power up the sensor. I'll go over these four pins in the next slide. Out is the pin that goes to the microcontroller to let it read the output of the signal. This datasheet is for the color sensor. S0 and S1 are the two pins that we set to get the desired output frequency, right? So if we set both to low, then we power down the sensor. If we set one to low, the other one to high, then we get 2%. And in my project, I'm using 100% frequency, and I'm setting S0 and S1 both to high. S0 and S3 are the two pins that we set to get the desired uh, to get the desired color. Motor. I'm using this motor to control the movement of the conveyor belt. I'm only using three pins out of it, and I'm not using the rest of the pins for this project. I'm using PWM, VCC, and ground, and the rest of the pins, most likely phase is for direction control, sleep is to enable, disable the motor, and MCU is most likely for feedback or additional control by the microcontroller. Potentiometer, I'm using this potentiometer to control the speed of the motor. And the motor is connected to the conveyor belt. So in results, I'm using this potentiometer to control the speed of the conveyor belt. I'm also using it to let the conveyor belt swing in two opposite directions. The way this potentiometer works is it measures variable resistance and then it converts that resistance to analog voltage. And then that voltage can be read by the microcontroller. It has three pins, ground, VCC, and signal. And the signal pin is the one that's being read by the microcontroller uh, to get the output voltage. I'm also using LEDs, resistors, breadboards, and wires, a mini conveyor belt, and obviously my STM32L432K board. Software, I'm only using STM32 IDE and Mobile Xterm. For connections and buses, I'm using PWM as an integration between the motor and the STM32 microcontroller. Input capture mode is between the TCS3200 color sensor and the STM32 board. ADC is between the potentiometer and the STM32 board. UART is between the STM32 board and Mobile Xterm. A quick overview of how these connections work is the TCS3200 sensor is interfaced with the STM32 microcontroller through GPIO pins using input and output communication. Input capture mode and then is integrated between the sensor and the board to measure the frequency output from the sensor. The motor is connected to the microcontroller through GPIO pins with the control implemented using PWM signals. Additionally, the potentiometer is connected to the microcontroller through the ADC, which is an analog to digital conversion. Lastly, the whole output of the program is being outputted to UART, to Mobile Xterm through UART for us to see the results. Test cases and results. For test cases, I have color detection. I included images that showing either the system is detecting colors or not. Uh, I have a conveyor belt. We want to make sure the conveyor belt moves correctly. Direction control by the potentiometer, as I said earlier, how the potentiometer should control the movement of the um, conveyor belt to make it swing in opposite directions. We want to make sure that works correctly. URs, we want to make sure that the program outputs the mobile term correctly. Test cases. Um, Here in this image, at the top right, I have the sensor is detecting a red color, which is an object on the conveyor belt. And I have my LEDs here for debugging purposes, which tells us that the sensor is working correctly. The one at the bottom, I have a green object on the conveyor belt, and it's given us a green color, which is correct. I have a blue color on the conveyor belt, and it's giving me a red LED, which is also correct. Test case for conveyor belt, I will demonstrate that in the demo video. Same thing for the direction control by the potentiometer, I will demonstrate that in the final video. And uh, these two are the same, sorry. And the output uh, for for um, for mobile extern. Uh, every time this works simultaneously with the with the sensor with the whole system, and when a color has been detected, I get the value of that color. I get a message that says this color is being detected. And when there is nothing detected, I get a message that says uh, color or object not detected. Now, let me show you a demo of the system. All right, here's a demo. Here's my potentiometer, and here is my motor is connected all the way, and my conveyor belt as well, and the sensor is hanged on a stand. And I have my LEDs uh, just for debugging purposes, and I will move it a little bit. All right, so now it's detecting that one of these books is green color, and it's also outputting that on the Movax term simultaneously. And here is a blue color, and here is red. Again, here is blue, here is green, here is red, blue, green,
red color.
And here is mobile Xterm outputting. It is a bit quick because I have a message that says um, object not detected or book not detected when there is nothing detected, but now it's detecting green. And here is blue, where it says blue is detected. And here is my red.